Students, today I am going to teach you about a few tidbits of using a psychrometric chart. For example, the dry bulb temperature of air is given and you are required to find out the value of saturation humidity. You can easily do it from the psychrometric chart. In the y-axis you have the humidity line, in the x-axis you have temperature, and then within the psychrometric chart you have percentage saturation curves like this. Fine. Now suppose this one is 100% saturation curve. So what you have to do, you first locate the dry bulb temperature, and then from this point you draw a vertical line which will intersect the 100% saturation curve, and then go towards the y-axis, find out the corresponding saturation humidity. It's quite simple. Okay. Then there is another issue of using a psychrometric chart. For example, the initial air condition is defined. The dry bulb temperature and absolute humidity values are given, and from that condition, suppose the air water vapor mixture is cooled adiabatically, and you are required to find out the corresponding adiabatic saturation temperature and the adiabatic saturation humidity. How to proceed? So this is the psychrometric chart. You have the y-axis humidity line, the humidity, absolute humidity, and in the x-axis you have the temperature. Then the first thing that you have to do is that the initial air condition is given. So suppose this is the dry bulb temperature of air is given, the corresponding absolute humidity value is provided. So you draw a vertical line from the dry bulb temperature, a horizontal line from the corresponding humidity, find out the point of intersection P. And then within the psychrometric chart you have the percentage saturation curves are given. So this is 100% saturation curve. Okay. And then within this chart you have adiabatic saturation lines. So these are basically adiabatic saturation curve or adiabatic cooling lines basically. So once you have this point of intersection P, and you know that the air water vapor mixture is cooled adiabatically, so from this point P you have to draw a line, or you have to interpolate a line. Okay. And it's quite simple that you have adjoining parallel lines are already present within the psychrometric chart. So keeping that in mind, you draw a line parallel to the adjoining lines in such a way so that it intersects the 100% saturation curve. Okay. And from this point you have to draw a horizontal line towards the y-axis, and you can easily find out the corresponding adiabatic saturation humidity. Come towards the abscissa and you have the adiabatic saturation temperature. Okay. It's quite simple. Now suppose in many a times the system may not be for air water vapor mixture. It's suppose an organic vapor is present in air, and you are supposed to find out the corresponding adiabatic saturation temperature and the corresponding adiabatic saturation humidity. In that case you simply cannot use the psychrometric chart because psychrometric chart is mostly meant for air water vapor system at 1 atmosphere pressure. However, there are charts available for organic vapor air system, but the better way of doing it is solving it algebraically. Okay. We already know that the adiabatic saturation curve is represented by this mathematical equation. y prime minus ys prime divided by t minus tas is equal to minus cs over lambda s. So this y prime stands for absolute humidity, ys prime basically stands for adiabatic saturation humidity, T is the dry bulb temperature, TAS stands for adiabatic saturation temperature, CS stands for humid heat, and lambda S stands for latent heat of vaporization of water. Fine. So if you can arrange this equation, on the left hand side it will be TAS, on the right hand side it will be T minus lambda S over CS ys prime minus y prime. So this is the equation. So once the air condition is defined, dry bulb temperature value is known, lambda S value is already known, humid heat can easily be found out, absolute humidity value is already given. So you are supposed to find out the adiabatic saturation temperature and the corresponding saturation humidity. It seems it's a single equation and there are two unknowns, so straight away you cannot solve it, but there is an alternative method of solving it, is solving it via trial and error. So how can you solve it? First you assume any value of TAS. You assume any value of TAS, and corresponding to the value of TAS you use Antoine's equation or Antoine's equation to find out the corresponding vapor pressure. To find out corresponding vapor pressure PAV. Once you find out the corresponding vapor pressure, you can use the standard relationship, which is for saturation humidity it will be the ratio of vapor pressure of A divided by total pressure minus vapor pressure of A, where A basically stands for the component water and B is basically for air. Okay, for normal water vapor air system, but if it is a suppose benzene in air system, then A will be the component which is vaporizing, which is benzene, and B is going to be the air, multiplied by molecular weight of A divided by molecular weight of B. You can find out the value of YAS using this relationship, and then once you find out the value of YAS relationship, put the value of YAS in this equation and try to see or check whether you get the value of the same assumed TAS or not. If the assumed value of TAS and the value that you got it TAS basically matches, then your approximation of TAS is correct, and that will be your adiabatic saturation temperature, and correspondingly YAS is going to be your adiabatic saturation humidity. So this mathematical equation can be easily used to find out the value of TAS and YAS prime, especially for organic vapor in air system, where you simply cannot use the regular psychrometric chart which is meant for water vapor in air system. Thank you very much.